We are going to begin this activity today by looking at some of the responses that were received on the survey that you took at the beginning of this unit. As you can see, we have 35 responses that have been received on this survey so far. And we're going to be looking at some of these different questions here. We're going to look at the gender question. Are you male, female, non-binary was a choice here, but nobody that completed the survey actually selected that option. So it looks like 65.7% of the people that took this survey identify as female. That was 23 of the respondents. And then 34.3% of the people that completed the survey identify as male. So that is 12 people that identified as male. And then we're also going to look at right-handed or left-handed. So 88.6% of the people that took the survey identified as being right-handed. That's 31% or 31 of the respondents, and 11.4% responded that they were left-handed. That is 4 of the people that responded. Again, we had another option here, ambidextrous, people who use their hands interchangeably with no preference for either, but nobody that completed this survey actually selected that option. So here I have all of the data from the survey in its raw form, whether a person is male or female, and whether or not they identified as being left-handed or right-handed. My first question here is, what are the variables? In this case, we have 2 variables. Gender is one of our variables. And the other variable is which hand somebody prefers. Okay, so we've identified our 2 variables. Are these variables that we're going to be talking about today categorical variables or quantitative variables? They are both categorical variables. And we are going to compare these 2 categorical variables. My other question before we really dig into things is, which one do you think would be the explanatory variable, and which one do you think would be the response variable? So gender is our explanatory variable, and hand preference is our response variable. So in comparing these 2 variables, a couple of the things that we're going to be looking for is there an association between these 2 variables? Is there a correlation? And if there is a correlation or an association, is that causal or not? Will we be able to determine that from this information? So take just a moment, and on your own, I want you to try to answer these 2 questions for yourself. Do you believe that there's a correlation, an association between gender and hand preference? And then also go in and answer for yourself that if we do find that there is a correlation, an association, or a relationship between gender and hand preference, do you think this is a causal relationship? We'll make sure to come back and answer those 2 questions definitively after we have been able to compare this data. So how exactly are we going to go about comparing gender and hand preference? A circle graph or a pie chart works really well when I want to display information about just one categorical variable. Like in this case, up on the screen right now, we have a pie chart for gender. But if I want to display the relationship between 2 different categorical variables, such as gender and hand preference, what can I use to do that? And the answer to that question is something called a two-way table. So I have created this two-way table from the data that was collected on the survey from all 35 responses. I have the information displayed here showing me males and females, left-handed, right-handed, and my grand totals. Okay, so very quickly in how to read a two-way table, and then we're going to start comparing these 2 variables here. So across the top, I have left-handed and right-handed and my grand total. And along the sides, I have male and female in the grand total. And so what I can see here is if I'm looking just at the left-handed column, we had 4 total people say that they identified as being left-handed. 3 of those people were male, and 1 of those people was female. If I look just at the right-handed column, I see that we have 31 people that said that they were right-handed. 9 of them were male, 22 of them were female. 4 plus 31 gives me the grand total of everybody that responded to the survey, which was 35 people. Now, if I look just along the row for female, I see that I had 1 female that said she was right-handed, 22 females that indicated 1 female that said they were left-handed, 22 females that indicated that they were right-handed, for a grand total of 23 females. Along the male row, I had 3 males identify as left-handed, 9 males identify as right-handed, for 12 males total. 23 plus 12 gives me 35 people that responded to the survey. So this down here, this is the total, as opposed to a row total or a column total. All right, we can start to answer a couple of questions using our two-way table here. So the first 2 questions that I'm going to ask and answer, what proportion is male, what proportion is female, these actually were shown in our circle graphs, our pie charts that we could see, because we're just looking at one variable. But I want to make sure that I know how to read this table. So when I'm asking what proportion is male, I'm saying what proportion out of all the people that took this survey are male. And so I would do P for probability or proportion. I'm going to use M as shorthand for male. If you remember looking up here, I'm looking at all the males. So we had a grand total of 12 males complete this survey out of 35 people who responded. And then I want to answer the same question, but I want to know now what proportion is female. So I'm going to use a capital P again for probability or proportion. And I'm going to use the shorthand of F for female. We had 23 females complete the survey out of 35 people total. And so I have 23 out of 35. Now with either one of these, males or females, I can convert those into percents instead of leaving them as fractions or proportions. So for the males, 12 out of 35, that is roughly 34% of the people that responded to the survey. And for females, 23 out of 35 is approximately 66%. Sometimes it's going to be more beneficial for us to look at it as a proportion or a fraction, and sometimes it's going to be easier for us to look at this information as a percent. So I want to make sure that I can go back and forth between those two. All right, and then we're going to answer questions 3 and 4. What proportion is left-handed and what proportion is right-handed? So I'm going to use a capital L as shorthand for left-handed, and I'm going to use a capital R as shorthand for right-handed. And again, we're looking at what proportion out of the whole population, out of everybody that completed this survey, is left-handed. So I know that my denominators on both of these are 35, because that's how many people we had complete the survey. Left-handed people, we had 4, and right-handed people, we had 31. So again, I can take both of these and change them into percents so that we can compare them that way again. 4 out of 35, that's approximately 11% of the people that completed the survey, and right-handed is approximately 89%. And then I have question 5 down here at the bottom, and this is when we start to get into these 2 variables together. What proportion is male and left-handed? So I'm still looking out of the whole population here. So male and left-handed. So I'm going to use M for male, and I'm going to use L for left-handed, and then I'm going to use this upside down U shape. This is called an intersection. It's also sometimes used with the word and. So I'm looking for people who took this survey that have both of these characteristics. They are, at the same time, male and left-handed. The reason that this gets called an intersection is when I look at the table, I'm going to find the row for male, and I'm going to find the column for left-handed, and where those two intersect each other is what I'm looking for. So there were 3 males that identified as being left-handed. And so my proportion is 3 out of 35, which is right about 9%. Now I want to start answering questions about what proportion of people that are left-handed or lefties are female and what proportion of lefties are male. So for both of these questions, I'm not looking at people that are left-handed and right-handed. I am restricting myself to only be looking at people that have identified as left-handed. And so every number that I get is going to come out of this left-handed column. And I want to know the proportion of people out of that column for this first question that indicated they are female. And so I'm going to put that first, F for female, and then I'm going to use this line. This is for conditional probability, and then I'm going to use an L here. So what this notation means is that when I'm looking just in the left-handed column, so I've restricted my view to just people that are left-handed, I want to know the proportion that are female. Well, there is 1 female out of all the left-handed people, which is 4, and so that would be the same as 25%. And then I come down and answer the question about what proportion of lefties are male. So again, I am restricting my view to just people that say they are left-handed, and I want to know which ones are male. So male, given that, or restricted to only people that are left-handed. 3 out of the 4 people that said they were left-handed also indicated they were male. And so that would be 75%. And now I've added a question 8 on here. What proportion of females is left-handed? At first glance, this might look like the exact same question that I asked up in number 6. What proportion of lefties are female? But this is different because now I'm starting off with the restriction of I'm only looking at my females. So I'm restricting my view just to the row of people that said they were female. And I want to know how many out of just those people indicated that they were left-handed. So the way I write my notation for that, I have P for, again, probability or proportion. I want to know, restricting my view to just females, how many of them indicated they're left-handed. So left-handed, given that, or with a restricted view to just my females. Well, there were 23 total females that answered the survey, and of those 23, only 1 indicated that they were left-handed. 1 out of 23 is about 4%. All right, one more question here. What proportion of males is left-handed? So if I want to answer this question, start off by telling me which row are we restricting our view to? Who are we looking at here? That's right, this time we are only looking at the males. And so I want to know about the left-handed behavior if I'm restricting my view or only looking at the males involved. So when I look at just the row for males, I see that there were 12 males that answered the survey, and of those 12 males, 3 of them indicated that they were left-handed, which is 25%. So looking at this information here, does there appear to be a relationship or a correlation between gender and whether a person is left-handed or right-handed? Well, I would say by looking at this, there does appear to be a relationship. It looks like if somebody is male, they're more likely to be left-handed than if the person is female. From this information, can we determine that being male causes somebody to be left-handed? Absolutely not. We cannot make that kind of leap here. This is a survey. This is not an experiment. People were not randomly selected to be either male or female, and so we cannot determine any kind of causal relationship here, but there does appear to be an association. If we wanted to determine whether males are more likely to be left-handed than females, which of the proportions that we have come up with would be most helpful or most relevant to consider? Would it be the proportions that we came up in questions 6 and 7, the 25% and 75%, or would it be the proportions that we came up with in questions 8 and question 9, 4% and 25%? If we wanted to try to determine this, the most relevant ones to consider would be 8 and 9. And the reason is because of the comparison that it offers us. In number 8, we are looking at, out of all of the females, what is the probability that that person is left-handed? And in 9, we're looking at, out of all the males, what is the probability that that person is left-handed? And so it allows us to make comparisons for size of groups. We had a lot more females respond to the study, so even if we had had 3 females and 3 males say they were left-handed, because so many more females responded, 3 out of 23 is a much smaller percent of the total females responding than 3 out of 12 for the males. And that's why we would want to use those two comparisons. Do you think the difference between left-handedness in males and females is significant? Well, in this case, answering that question, it's kind of hard to say. We only have a sample size of 35 people, and that's a very small sample size. However, the difference between 4% and 25% does seem to be large enough that it would be fair to say that there's probably some significance here, but how big or how small is really hard to say because of our very small sample size.